We have some new important vocabulary words here that you may have heard of, but I want to really distinguish between them and let you know how we're going to be using them in this class. So the first term is inertia. Okay, inertia is a term that you might have heard before. Inertia is the tendency of an object to resist acceleration. Okay, so what that means is the harder it is to get an object to accelerate, the more inertia that it has. Okay, so if you imagine you're trying to get an object to accelerate, maybe it's at rest and you're trying to get it to go to a huge velocity. How hard is it to get that to happen? You know, if you have something like a balloon, it's very easy to get that balloon to accelerate. You could just give it a tap and it's going to accelerate very quickly. That balloon has a very small amount of inertia. Compare that to something like a bowling ball or an elephant on roller skates. It's going to take a huge amount of force to get a bowling ball, or let's say an elephant on roller skates, to accelerate. You can't just give it a tiny little tap and expect that elephant to start accelerating. You have to give it a huge amount of force. That's because the elephant has a large amount of inertia. Okay, so what is inertia? And if you have trouble with these terms, I want you to write these definitions down. Maybe write down an example with a balloon and a elephant, and just come back and read that over and over and over again and ask yourself, what is inertia? Because we're going to use that term a lot. Okay. Another term we're going to use is mass. Mass, you might recognize, is something that is measured in kilograms. So you might think, oh, well, kilograms is kind of like what in America we use pounds. So mass is probably the same as weight. Well, they're a little bit different, so I want to distinguish between them. Mass measures how much inertia an object has. Okay, so things that have a lot of inertia, like an elephant or a car, these are things that are heavy. They have a lot of mass. But the heaviness has to do with gravity. So we want to be able to distinguish between mass and weight. So for now, I'm just going to say mass is measuring how much inertia the object has. It is related to how much it weighs on Earth, but there's a difference when we leave the Earth. Okay, so when we're on the Earth, mass and weight are very much related. They're directly proportional to each other on Earth. Something that's very, very massive also has a big weight. Okay, but weight is very specifically, as we described before, the force of gravity on an object. Okay, and like I said, on Earth, these two things seem like they're the same. The difference comes when you go into outer space. Okay, so let's consider a bowling ball in outer space. So you're in outer space, you're in a little spacesuit, you're floating around, you have a bowling ball. In outer space, there's no gravity. Because there's no gravity, the force of gravity on this bowling ball is 0. That means its weight is 0. So in outer space, this ball is weightless. I could balance it on my tiny little pinky fingernail, and it wouldn't hurt me at all. Okay, I could carry this. It would be very easy for me to carry this. Whereas on Earth, where the force of gravity on this object is large, I would never be able to balance this on my pinky fingernail. I would have trouble carrying this. It would be very heavy. It has a large weight. The force of gravity on it on Earth is big. When we go into outer space, it's easy to carry because its weight equals 0. It is weightless. There is no gravity on this object. Okay, so weight depends on gravity. When there's no gravity, there's no weight. However, mass is independent of gravity. It just measures how much inertia the object has. This still has mass in outer space. However much mass this has on Earth is the same as its mass in outer space. That doesn't change. Mass has nothing to do with gravity. It's just a matter of how many atoms are there in this bowling ball. So this will still have the same mass. It will still have a large mass. So what does that mean? If I take this bowling ball into outer space and I try to shake it back and forth. So imagine I'm shaking it here and I'm shaking it here and I'm shaking it here and back and forth and back and forth. That object is accelerating because first its velocity is to the left, then its velocity is to the right, and its velocity is to the left and to the right as I shake it back and forth. So as I shake it back and forth, I'm constantly changing the velocity. That means I'm constantly making it accelerate. And you know what? It will be difficult to shake this object back and forth. If I brought a balloon into outer space, it would be easy to shake back and forth because it has a very small amount of mass. The bowling ball in outer space it has a large amount of mass. That makes it difficult to make it accelerate. It makes it difficult to shake back and forth. Okay, so come back to this slide. Think about a bowling ball in outer space when you're trying to distinguish between weight and mass and how they are different. Because on Earth, they seem like pretty much the same thing. Okay, this brings us to Newton's first law, which you may have heard of. If you've heard of it, you've probably seen it in some weird commercial, like maybe like a Gatorade commercial, where they show some guy like watching TV on the couch, and they're like, objects at rest tend to stay at rest. And then they show some like super fit guy jogging down the street drinking Gatorade, and they're like, objects in motion tend to stay at motion. So that's Newton's first law, but it's really only part of Newton's first law, and the part that it's missing is the most important part. So let's read the real Newton's first law. Objects in motion tend to stay in motion. Yeah, that's the guy sitting on the couch. Oh, no, wait, sorry. That's the guy jogging. Objects at rest tend to stay at rest. That's the guy sitting on the couch. But the most important part is, unless acted upon by an external force. That's really the key. Okay? So this is also called the law of inertia. Okay? Objects that are in motion will stay in motion, and that really means with a constant velocity, unless they are acted upon by an external force. Objects at rest, so this means objects that have a velocity of 0, will keep that velocity of 0 unless they are acted upon by an external force. In terms of an equation, here's how we could represent this in terms of an equation. I could say delta V is equal to 0. Think about what that means. That means the velocity is constant. This first term here means velocity is constant because the change in velocity is 0. This symbol here is a philosophy or a logic symbol that means if and only if. So the velocity is constant if and only if the acceleration is 0. We already knew that. But now the new piece we're saying is these two things are true if and only if this piece is also true, that the net force is 0. So this symbol here means that if one of these is true, you know for sure that the other two things are true. It's impossible for any one of these to be true and not have the other two be true. So if this is true, that means this is definitely true and this is definitely true. Or if you know the acceleration is 0, then you definitely know the velocity is constant, and you definitely know the net force is 0. If you know the net force is 0, you definitely know the velocity is constant, and you definitely know the acceleration is 0. I want these three things to be linked together in your brain, so that if you hear any one of these things, you immediately know the other two are true, and you almost have this involuntary reflex to just shout out, acceleration is 0 and net force is 0, every time you hear someone say velocity is constant. Okay? These three things always go together. Okay? And one other piece that's going to go with those three things is the word equilibrium. So equilibrium means velocity is constant, acceleration is 0, and net force is 0. We have two types of equilibrium. One is called static equilibrium. That's when an object is at rest. Okay? So this object is at rest. It is in static equilibrium. The motion diagram would just look like this. What does static equilibrium mean? It means that the velocity is constant, it means the acceleration is 0, and it means the net force on that object is 0. But we can also have something called dynamic equilibrium. So equilibrium again means all of these things are true, but dynamic means the object is also moving. So it is possible for an object to be moving and still have the net force on it be 0. Let's consider someone on a skateboard with no friction. They're moving forward at a constant speed. This is what their motion diagram would look like. So again, they're moving forward at a constant speed. Because they're moving in a straight line at a constant speed, the velocity is not changing. The velocity is constant. That means their acceleration is 0, and the new piece here is that means the net force on this object is 0.